So hello and good morning, everyone. So welcome to this webinar, also on behalf of the HEXA-X-II project and also on behalf of myself. My name is Nurul Mahmood. I'm from the CWC, Center for Wireless Communications at the University of Oulu, and I'm the PI for this HEXA-X-II project. So maybe a little bit about the HEXA-X-II project, just for those of you who are not aware of the project. As Yab mentioned, we already had a similar webinar last time, but many of you are aware, but just to make sure that we are all on the same page. So this project is a 3-year project that started in September 2023. So we are almost in the middle of this project now. And it has 2 main partners, the University of Oulu from Finland and Mid-Sweden University from Sweden. And a PI from Mid-Sweden University, Mahmood, is also here online, and he will have a presentation later today. We also have 2 associate partners, so they are not getting any funding from the project, but then they are still contributing in kind by providing their expertise. From Finland, we have Soli, so there's a typo here, it's Solita, that's an IoT company, and then we also have Starbit, which are making IoT devices in Sweden. And then we have some sort of advisors, Viola, that's the Finnish operator of the rail network in Finland, and Drone Innovation from Sweden. So that's the project consortium. So what's this project about? As you mentioned, the remote connectivity or rural connectivity is the red line that's connecting these 2 projects, and also that's the thread that's somehow connecting the different work packages within our project. So basically, the project goal is to look into efficient connectivity solutions. We have 2 goals. So the first goal is to look into efficient connectivity solutions, and the second goal is to look into remote sensing techniques, mainly for remote monitoring of the logistic infrastructure in remote areas. So as you can see here, you have different pictures of logistics infrastructure. So we have the, let's say, trucks and so on, but we also have the rail network. So these are different examples of the logistics infrastructure that we are targeting as use cases. And then we are basically trying to see first, how can we provide efficient connectivity solution, wireless connectivity solutions for these use cases? And second, how can we use remote sensing techniques to improve the, let's say, remote operation of these use cases? So that's basically the main goal of this project. And of course, the objective is to have this kind of maintenance, reduce accidents, improve efficiency, and so on. So in terms of the project goals or outcomes, so we have short-term and long-term goals. Short-term goal is, of course, to first of all make sure that this project completes successfully with with some good results, and also probably to spin off into new proposals and new research ideas that we can continue further with the collaboration, and then disseminating this the outcome of this project, for example, through this webinar and also other similar events. Okay. And then in terms of the long-term goal, so we have 2. First is the, let's say, flagship status in supply chain digitalization and automation. So basically to really look into, effective solutions or long-term solutions for this infrastructure problem, because you know that in remote areas, this is the main problem, that we have this logistics use cases and we need to provide efficient solutions for those. Right? And then the second one is not the technical, but it's more on the, let's say, impact of this project is to create this North Nordic ICT belt and to attract more talents to this region, because you know that this is also one of the challenges that are being faced in these remote areas, basically attracting and also retaining talents to ensure the development of this region. So the title of this talk talks about resilient network. So I just added this slide to tell you about what do we mean by resilient network. And this is a topic that we are discussing a lot within HEXA-X-II Flagship and within CWC, especially because we believe that resilience would be one of the main keywords of 60 and beyond 60 networks. Okay. So, of course, there are also other similar terms, for example, reliability, robustness, dependability, and so on. So how does resilience differ or resilient differ from these other terms? So one thing, for example, the closest, let's say, existing solution that you can find to resilience is URLLC as defined in 5G. And that's basically telling you that, okay, we need to guarantee certain reliability and certain latency guarantees for communication, right? But URLLC as defined in 5G has some limitations. So first of all, it's not application aware. And as we all know that different applications have different requirements. So you cannot just say that, okay, I need reliability 10 to the power of -5. And it's not like one size fits all, right? You may have industrial applications that requires 10 to the power of -5 reliability, but you may also have other applications that may require, let's say, 10 to the power of -2 reliability, right? So that's one thing. The other thing is that URLLC focuses mainly on reliability and latency, as the name suggests, as the KPIs. But when you talk about resilience, there are also other KPIs. So one example can be that if, suppose the network fails for some reason, right? How long does it take for the network to come back to its normal state, right? So time to recover. And that's an important metric that's not covered in current URLLC in 5G. Then also the other thing is the scalability, because URLLC as defined by 3GPP is for the link. It's defined for layer 2 link. But then we all know that wireless networks is not limited to a single link, right? Wireless is a multi-hop network. So how do you scale URLLC to the whole network, right? And of course, when you talk about resilience, you cannot avoid the term security, because security is an important pillar of resilience. So basically, if you want to talk about resilience, we believe that to make a network resilient, it should be application aware. So you need to provide different quality of service guarantees for different applications, and you need to be able to differentiate between different applications. Secondly, of course, we need to also expand the horizon and going beyond reliability and latency to talk about other KPIs. Thirdly, scalability is very important, because wireless networks, as you know, is not just limited to a single hub or even to a, let's say, local area network. So when you scale things, then of course you have different problems that need to be solved. And finally, security should be built in by design to make networks resilient. So this is addressing the first part of the title of this talk, so resilient networks. Secondly, then let me also give you some updates of what we have been doing in this project. Of course, so one aspect of this resilience is the connectivity solution, right? And as I said, in this project, we are looking into two different problems. So one is the efficient connectivity solution, and then the other is remote sensing. So in terms of the connectivity solution, as you can see from this figure, which also will be expanded further by my colleague Jian in his talk later. So Starlink, you can see it has very good coverage in mainland Europe, but when you look at the remote region in Finland, let me just use the laser pointer here. Yeah, so you can see that it's not very well covered. And this is as Yap, you mentioned, this is the main challenge of remote regions, right? Existing solutions are not sufficient for these remote regions. So we were thinking that can we have, of course, another option would be to have UAVs hovering above, but then you know that UAVs, since they're like at 50, 100, 200 meters, so their coverage region is very limited. So an intermediate solution that is between UAVs and satellites is HAPS, high altitude platform systems. So basically, these are flying devices that can be static. They're around 10 to 20 kilometers above the ground. So they're above the stratosphere. So you do not get many of these atmospheric challenges, but then they can be a solution to provide connectivity covering a wide region, right? So this is one thing that we are investigating in this project. And I have here, of course, one result that just shows that in our, let's say, preliminary study, we have tried to evaluate what would be the performance of a HAPS-mounted LoRa network. So you have here HAPS height. So when HAPS is at different heights, and you have here the distance from the origin to the network to the border. So basically the radius of the coverage region. And what is the success probability of connections or coverage probability of connections with different LoRa spreading factors? And you can see here that, for example, with SF12 or with LR FHSS, we can get quite good coverage probability, even with large covering a large area with a large radius, right? So this is, of course, some initial results that we have been investigating. And as I said, my colleague Xian will provide you further details, so I will not dwell on this any further. Then the other part of our project is to look into this data fusion techniques, or let's say remote sensing techniques. So the main thing is that how can we use sensor data? So maybe I will go to the next slide first and then come back to this one. So how can we use sensor data, different data from different sources? So you can see multimodal data. So not only sensor data from the, let's say, logistics operation, but also data from other sources. And how can we use this to do predictive maintenance so that we can have much more efficient logistics solutions, right? So one thing that we are investigating now, as you can see here, is the use case of the rail network. So basically, to look into the impact of the weather on the delays in rail traffic in Finland. So we have collected data from the Finnish rail operator of the delays across a large number of periods, so across multiple years, the delays in each station. And also together we have collected the weather data from the Finnish Meteorological Institute. And now we are trying to collate this information and trying to find the correlation between the weather and the delay. And then first step is to find the correlation, and the second step would be to come up with a predictive model, so that by just looking at the weather forecast, we can try to predict what would be the delay at a given station. Of course, it's not as easy as it sounds, because you have different artifacts at different regions. So for example, in the north, snow is one of the main contributing factor. In the coastal area, then the wind speed is a big factor. And then in the south, you have other parameters that impact this delay. So this is a work that is ongoing, and hopefully we'll soon be able to publish our initial results in some conferences. So these are the, let's say, two arms of this project that we are looking into. And then I will go back to this slide here. So semantic communication is also one part of this, where we are trying to answer the question, like how can we make the transmission of this information more efficient. So in this case, you have this remote operator that is doing this remote operation of timber, these trucks that are carrying timber. And of course, as you can see here, you need to send a lot of images here. And that, of course, imposes that's a bottleneck on the connectivity, because you need a lot of big data pipe to send these images, right? So we were asking the question, can we use semantic communication to make this much more efficient? Because you have a lot of images, but then we do not need to send all those images. So if we can find a way to extract the useful information from this image, and then only send that information, then of course the connectivity becomes more efficient, because you need a smaller pipe to achieve the same thing. So that's also another thing that we are looking into, and probably my colleague Amir will detail this a bit further. So. Okay, so and then the last thing that I would just say here very briefly is that there's also this problem of sun curve monitoring, and we are trying to build some devices, some sensor devices that can try to sense the rail tracks, so that we can predict the sun curves, because you know that this is a big problem, especially in the summer, because although we are in a cold region, but then the summer can be very hot, and then you get this problem, because these sun curves do not only depend on the temperature, but it also depends on how fast the temperature is changing. And this happens often in this region. So we are looking into building sensors to try to address this problem as well. Yes, so with that, that's the last slide here. So I just, to summarize, I just gave you a very quick glimpse of the different aspects that we are researching in this project. And we are 1.5 years into the project, so we have made some progress, but hopefully the next 1.5 years will be reaping the benefits of this progress and coming up with all the publications and the results. Yes. With that, thank you very much for your attention.
Good. Thank you, Nurul. So there is room for some questions, if there are any. I have one or two questions. So I was wondering on these new KPIs. On one of your first slides, you mentioned the new KPIs, and you mentioned up the time it takes to recover for a network and so on. Is coverage by itself? Do you consider that a KPI? The mere you go later on into the details of rural remote coverage. Is that?
Yeah, I think that's a very, very good question, and that's of course something that we are looking into. So,
and also probably sorry for interrupting, but also it is related to the service. There's not one kind of coverage, perhaps.
So that's actually connects to this application awareness. That what is the service availability, and that's more that's maybe the more accurate term. So like, when is this service available in this region, right? And that's of course an important KPI that has been overlooked, but that we believe it's important for resident network, because in remote areas, then coverage or service availability is an important metric to consider.
Yes.
Then you basically have to be aware of connectivity of various different communication methods and link that to these services.
Yeah.
Yeah, good. Perhaps one other question I was thinking of this: if Starlink, and you showed the map of the coverage map of Starlink, for instance, right? If that is meant for remote areas, so how come? Do we understand why the deployment is as it is? Why do they deploy so much fewer satellites in the polar region? Do we understand the business ideas? And is this a threat, or is this a concern, right? Because we hear that Starlink and satellite communications are going to solve our coverage problems, right? Well, will it solve it?
Yeah, I don't know, but I think that this is the scarcity of the people and how much you can earn money from these people. Probably in the area where it's very scarce, there is living only 7 to 10 million people, and in Central Europe, it's in one city 7 million people.
Yeah,
but they are not using Starlink, so
no. So I think it seems to me a point of concern that the promise that we are giving people for that's LEO satellites are going to solve everything for everyone. Well, it may not be the case, right? If operators eventually tend to deploy the satellites constellations in a certain ways.
Even this scarce number of satellites is currently enough, but if there will be more users and per beam, then not anymore. Yes.
Okay. Thanks again, Nurul, for this first presentation.
Okay, thank you.
So let's move on in the agenda. The second talk will be from the Arctic 6G project, and so that talk will be given by Mikael Nilsson. So I hand over to Mikael now.